In this video, we're going to look at our final two examples of applying the property of logarithms to solve logarithmic equations. So if I take a look, I have log base 3 of 5x plus 5 minus log base 3 of x squared minus 1 equals 0. First thing I'm going to do is identify the property of logs that I'm dealing with. I see I am subtracting logs. That's like subtracting exponents, which occurs when you're applying your quotient rule. So we are going to do the quotient of logs property. So that means to combine them together into one log base 3, I have to take the quotient of my expressions. And so I'm going to have 5x plus 5 over x squared minus 1. And that is equal to 0. Again, if we take a look, we notice we have only one log. And so when that happens, we have to convert to exponent form. To convert to exponent form, remember, if you have log base b of n equals p, what that means is the b is your base, the p is your power, and it's equal to the value of n. So that means I really have the expression 3 to the 0 power equals 5x plus 5 over x squared minus 1. So this is going to be fun to solve. First thing I would do is I would simplify. What is 3 to the 0 power? Well, anything to the 0 power is 1. And so I really have 1 equals 5x plus 5 over x squared minus 1. So the question is, how am I going to solve this? Well, what I'm going to do is I am going to, in a way, look like it with cross multiplication. I'm going to imagine this 1 is really 1 over 1. And so I do 1 times x squared minus 1, which is just x squared minus 1. And 1 times 5x plus 5 is really just 5x plus 5. Since it's a quadratic, I'm going to get everything on one side, and I get x squared minus 5x minus 6 equals 0. So to solve this, I'm going to factor. I want numbers that multiply to give me negative 6 and add to give me negative 5. So that's x minus 6 and x plus 1. So to solve, x minus 6 equals 0, so x is 6. X plus 1 equals 0, x is negative 1. We have to verify that both of these answers work by plugging them in. If I plug 6 in, I get a positive number here and a positive number here, and so we know 6 works. If I plug negative 1 in, I get a 0. We know we cannot take log of 0, and so therefore this negative 1 does not work, because when you plug it in, you get log base 3 of 0, and the definition of log says you cannot take the log of 0. So therefore our answer is just x equals 6. Let's try example 8. If I have log base 3 of x equals 1/4 log base 3 of 16 plus 1/3 log base 3 of 64, how am I going to solve this? Well, the left side is completely simplified, log base 3 of x. However, on the right side, I notice I am multiplying my log, which means you're multiplying exponents, which is your power rule. Same thing over here. I'm multiplying to a log, which means I'm applying my power rule. So to combine these, I'm going to first do log base 3 of 16 to the 1/4 power plus log base 3 of 64 to the 1/3 power. Before I go further, I'm going to apply this rational exponent to each one. So left side's going to stay the same, log base 3 of x. The right side, I really have log base 3. The 1/4 power of 16 is 2, plus log base 3. The 1/3 power of 64 is 4. Now I'm going to take a look. I have here adding of logs, which means I'm really applying my product rule. Notice on this example, I applied my power rule first and then my product rule, just like order of operations. So to combine the right side together, I'm going to take the product. So I have log base 3 of x equals log base 3. And really, the product, my right of the side, is going to be of 2 and 4. That's easy, that's 8. And so log base 3 of x equals log base 3 of 8. Since we have one log on the left and the same log on the right, all by themselves, we can cross them out, and we get the statement x equals 8, which if I were to plug in, verifies my definition of logs, so therefore it is our solution. So hopefully you found all these videos dealing with the properties of logarithms and using them to apply to solve logarithmic equations helpful. Make sure when you have multiple properties inside an equation, you look at it like applying your order of operations for solving. We deal with our exponents first, and then we would apply our product or quotient rule next.